Now you are going to see the step-by-step process of conducting a hypothesis testing or statistical data analysis. All the statistical data analysis or hypothesis testing begins with a scenario. So here you can see the scenario again, and the scenario depicts about a school that implements a new teaching method, and it is aiming to improve students performance, and the school administration is interested in knowing whether the new teaching method has a significant impact on the average exam scores compared to the traditional method. However, second steps will be to determine your null and alternative hypothesis. You can see the null hypothesis is the average exam scores of students using the new teaching method are the same as those using the traditional method. So there is no difference. Alternative, the average exam score of students using the new teaching method are different from those using the traditional method. So there is a difference, right? Okay, so we have developed our hypothesis. In the next steps, we have to choose our significance level, or the probability or the maximum probability at which we are willing to take risk, not more than this, to consider our decision may be false. However, you can see we have defined our significance level as 5% or 0.05 as per the worldwide accepted threshold. Proceed to the next slide. You can see our next step is to determine or ensure the normal distribution of our numeric variables. So, normal distribution or bell curve is a fundamental concept in statistics and probability theory. It describes a symmetric bell-shaped probability distribution characterized by the certain mathematical properties. You can see here three graphs. So at first you can see this graph. In this graph you have defined a cross sign indicating this particular graph is not the normal distribution, or the graph doesn't follow the normal distribution. You can see the distribution is slightly right skewed. That means the peak of the distribution is not in the middle of the graph, rather the left side of the graph, and the slope is higher at the right side of the graph. So in this particular scenario, we say such distribution as positive or right skewed distribution. You can see another graph here with a cross sign indicating this is also not a normal distribution, because the peak is at the right side of the graph and the slope is higher at the left side, indicating this is a left skewed or negative distribution. And you can see this particular graph. This is the graph that actually follows the normal distribution or bell curve. You can see a blue color curve which is called the bell curve, and you can see the peak of the distribution is at the middle of the graph and the slope are approximately equal at both sides. In this particular sense, you can say or conclude the distribution of this particular variable is normal distribution. Before testing any hypothesis, the numeric variable must follow the normal distribution. So the distribution must be checked, and if it does not follow the distribution, several techniques you will learn in the practical session to apply to transform the distribution near normal or appropriately normal. Proceed to the next step. In this particular steps, you are going to select the statistical test required for the analysis to test the hypothesis. So you can see a table. In this particular table, I have provided the three kinds of hypothesis you will deal mostly in your work life while dealing with data, and you will also use these three types of analysis most. You can see the first hypothesis where I say that there is a significant difference in something among two or more groups. So you are measuring the difference in something among two or more groups. In this particular sense, you have to use the one-way ANOVA. However, in our case, the hypothesis is said to make any difference in the students performance scores or exam scores between two kind of scenario, one scenario or one group that has the numbers or exam scores of students for new teaching method, and another group has the number of students exam scores for traditional teaching method. So in our sense there are two groups and we are measuring the difference on students performance. So we are about to conduct the one way ANOVA as per our scenario. So the selected statistical test as per our scenario will be one way ANOVA. If you find any hypothesis like there is a significant relationship between or among numeric variables, you have to use the correlation test. Or if you see you have to measure the significant impact, influence, effect of one or more variables to another variable, you have to use the regression analysis. You will learn more about such statistical tests in the practical lessons. Proceed to the next slide. You can see the next step is to make decision, where you examine the p-value obtained from the statistical test. If the p-value is less than a chosen significance level, and in our case it is 0.05, we will reject our null hypothesis. And finally we will make conclusions. So if the null hypothesis is rejected, it suggests that there is a evidence to support the claim that the new teaching method has a significant impact on average exam scores compared to the traditional teaching method. And if the null hypothesis is not rejected, it indicates that there is insufficient evidence to conclude that the new teaching method is different from the traditional method in terms of average exam scores. So this is the complete steps of conducting hypothesis testing. And in the next part you are going to learn how to apply the one-way ANOVA, the correlation test and regression analysis to derive some insight based on some hypothesis as per our data sets. That's all. Thank you.